As part of its commitment to fighting climate change, Hydro-Québec has been monitoring the greenhouse gas emissions of its facilities since 1993. Thanks to reliable and rigorous studies carried out in aquatic and terrestrial environments, Quebec is home to the world's most extensive datasets on the net GHG emissions of hydropower reservoirs. There are two main greenhouse gases associated with terrestrial environments: carbon dioxide, or CO2, and methane, or CH4. Two processes cause these gases to circulate in ecosystems: photosynthesis and respiration. During photosynthesis, which occurs in the daytime, plants absorb carbon dioxide. At night, during respiration, they release carbon dioxide into the atmosphere. At the same time, soils also release carbon dioxide and methane. This respiration occurs continuously as organic matter decomposes. Data is collected to establish a balance sheet called the Net Ecosystem Exchange for the two processes. To draw up the balance sheet, different methods are used to measure the GHG flows. Static chambers are one of those methods. They're placed on the ground or on plants for a few minutes to measure the concentrations of the gases that accumulate based on the principle of equilibrium. The chambers communicate with a measuring instrument in the field that quantifies the GHGs in real time. Light chambers are used for photosynthesis, and black ones are used for respiration. They're placed in different locations to create a snapshot of how the emissions vary. Automated chambers connected to a controller, an analyzer, and solar panels are also used. The measurements, which are recorded autonomously, help determine emission variations over time. To obtain a balance sheet that's as representative as possible, measurements are taken on different types of soil and vegetation. Some factors, like the groundwater level and soil temperature, influence the emissions. Piezometers and temperature probes help take them into account in the net ecosystem balance. Another method to measure GHGs is the eddy covariance technique, which allows for the calculation of emission flows directly in the atmosphere, thanks to high-frequency instruments that take 10 readings per second. They're often installed on measurement towers, in peat bogs, and forest environments, Quebec's two main terrestrial ecosystems. These gas concentration measurements are then used to calculate the net balance of the ecosystem under study per square meter. Based on this information, experts can then estimate the net GHG emissions related to building and operating a reservoir. Because different techniques are used to measure GHGs, teams of specialists are dispatched across Quebec. By boat, by seaplane, in peat bogs, and in forests, we do everything we can to methodically monitor and document the GHG emissions of our facilities. That's how we can confirm that Quebec hydropower is an energy source with low GHG emissions. And we've got the data to back it up.